Missed all of you the last 2 years. Brian, in his 106th day, but who's counting? He's come on very strong. We're very, as a board, we're very pleased with the selection we've made, and I'm sure our members over the next year or so will get to know him quite well, and will be as proud of him as we are. Just a few words on sponsorship, membership, and all of you in the room that have come to our conference this year. I want to actually not only thank our 23 sponsors, our 2023 sponsors, but I also really want to give a shout out to our sponsors for back in 22. Coming out of the pandemic, the conference in 2022 was always going to be a bit of a challenge. PTC pretty much led the way post-pandemic with the first conference of 2022, with others to follow. So it was always going to be a bit of a, I suppose, a gamble to see how successful 2022 was, and quite frankly, it was very successful. So I think it's really important to recognise that the PTC community got behind PTC for 2022. The sponsors came along on the journey with us in what was going to be an interesting conference, being a hybrid conference. And I just wish to thank them for sticking with us and being part of the PTC community. So thank you very much to all of our sponsors, past and present. Moving along, today's presentation, or opening presentation, I just want to say a few words about Cogent Communications. So let's talk about the internet. I mean, it is the backbone of today's world. It's powering our education, it's powering our economies, it supports our health and well-being, and it keeps us connected with neighbours and people that we love. I think it's important that people sort of get this into their head, that access to the internet isn't a luxury, it is a necessity. And with that in mind, I'd like to introduce Dave Schaeffer. He's the founder and CEO of Cogent Communications. Dave?
Thank you. Good morning to everyone, and I appreciate you getting up early and hearing this first presentation. I'd like to thank PTC for a great forum, and hopefully I'm going to try to fill in a few blanks for people. You know, my talk today is about why the internet matters more than ever, particularly for the Pacific region. And maybe a little bit of history of PTC would be helpful as background. You know, PTC started really when the world was dominated by voice and data was insignificant. And first satellite, then subsea cable, and now oftentimes data centers, cache content are all part of the internet and the Pacific region. You know, the internet has transformed this industry. For any of you that have been in telecommunications for a long time, it's been a tough ride. The internet is very deflationary. The average price per bit, that is kind of the way we measure our revenues on the internet, has fallen at a compounded rate of 23% per year. And whether you view this as good news or bad news, that rate of price decline is going to continue going forward. The internet today dominates traffic globally, and the internet is the network of the future. You know, we were lucky enough when we founded Cogent 23 years ago to make that bet that the internet would be the only network that mattered. And today, it's more relevant than ever. So as you look at the ability to drive down that pricing, it's based on two fundamental technologies: wave division multiplexing for optical transport and optically interfaced routers to direct those packets to the correct location. The internet is not a network. It's an amalgamation of networks. And it is really that level of connectivity that has allowed the internet to flourish. It is the most interconnected of all networks. It's a network that was predicated on a bill and keep model, which is sometimes an anathema to legacy telco providers who really wanted to act as gatekeepers and charge tolls to reach their end users. The other key attribute of the internet is it was a network that had no specific purpose. It was an open architecture. And then finally, it was a network that sat on top of other networks. So as you think about how the internet today is delivered, there are 4 primary last mile access network technologies that deliver internet. Wireless, now migrating to 5G, particularly important in less developed markets. Twisted pair, struggling in many markets because of the ultimate limitations of that technology. Coax cable, which has really dominated broadband connectivity to end users. And increasingly, we're seeing a fiber overbuild to last mile endpoints. And eventually, it is in the world's best interest for that to occur, to get every person connected via fiber, because the cost of delivering those bits on fiber is at least 3 orders of magnitude less than on those other technologies. And what we are seeing is a significant increase in private capital around the world to deploy fiber to the end user. And that is going to create yet another wave of traffic growth and innovation. And the reason why the internet matters so much is how many people are connected to it. There's about 7.5 billion people in the world, and about 5.3 billion of those individuals have regular access to the internet. That's the majority of people globally. The second reason the internet is so important is that it empowers the development of new business models. So now we have the possibility of literally 5.3 billion entrepreneurs globally coming up with new applications and new services. The beauty of capitalism is that it tolerates failure. And many of these new models will fail. There'll be many in a crowded market. A few will succeed, many will fail, and many of them may just not be viable ideas. But it's really that level of innovation that we, as telecommunications professionals, are empowering and allowing to occur. If we look at the developed world for the past 25 years, basically 1% of real GDP growth per year has come from innovations brought by the internet. We oftentimes talk about globalization, the outsourcing of manufacturing to lower cost labor markets. But really, what the internet is doing is flattening the world. It's putting everybody on an equal footing. And we're seeing faster growth in markets that have traditionally not had the same level of teledensity as the developed world. These are all positives. What drives internet traffic growth are really 3 things: number of people connected, number of minutes a day that they're connected, and then finally the bit intensity of the applications that they are using. And what we saw with the pandemic was a great example of how this technology rapidly morphed and adapted to a changing world. You can't imagine the level of remote work and productivity that continued throughout the pandemic occurring 10 or 15 years ago, when the internet was much less prevalent and much less capable. So it has really been the infrastructure that we have built that is allowing this to occur. Now, as we go forward, two things are happening simultaneously. The first is, as telecommunications professionals, we're relentlessly driving down the cost per interface routed bit mile. That sounds like a mouthful. As an internet service provider, and probably everyone in this room is in some way an internet service provider, whether it be to last mile end users, middle mile, long haul backbone, content delivery. In every one of those cases, that cost is coming down because we are deploying these new technologies. And the good news is we're much further away from hitting physical limits than we would in a world where we're developing microprocessors or storage. You know, everyone is familiar with Moore's Law. 53 years of compounded 55% price performance improvement in millions of instructions per second. But that improvement is starting to hit up against the constraints of materials technology. You know, we're moving now to a 3 nanometer trace world. Fabs are going to cost $8 or $10 billion and take close to a decade to deploy. And we're literally reaching the limits of silicon separation in transistors. The second way we increase throughput in computing is by using faster clock speeds. Moore's Law has taken advantage of both of those technologies. But as we improve clock speeds, we end up generating more heat. The chips become less able to dissipate that excess heat. And we're already seeing limitations on the ability to cool those chips down and keep those productive and functioning as they were designed to. So as a result, we are going to start to see a slowdown in the rate of improvement in computing. There's a second debate that's going on, which is where does information reside? Does it reside in a core data center? Does it reside in edge computing? Or does it reside with the individual? And the answer is all three. But the reality is the world has shifted in terms of where computing is occurring. 25 years ago, 90% of the MIPS produced in the world were produced on a Wintel platform. Today, over 90% of the millions of instructions per second are occurring on cell phones. The ability to distribute that computing to the edge has really transformed the world. It's lowered the cost of computing and allowed for the rapid dissemination of information. There is a need to centralize computing. Some of that will be in a distributed model. It takes about 300 locations globally to have an optimal cache infrastructure, to be close enough to end users that latency is irrelevant. But there's a third layer. The third layer is where large amounts of data are stored and processed. We all talk about hyperscale activity. Hyperscalers have centralized their models on about 40 major data center deployments globally. So as you think about the hierarchy of information, both storage and processing, it's like a wedding cake. It's in 3 tiers. You have the largest amount of information contained in those very large data centers, basically warehouses of computing and data. We're talking about facilities that are in the order of 100,000 to 200,000 square meters and can have a full gigawatt of power dedicated to them. And we're going to continue to see those facilities built. We're actually at the point now where over 4% of global power consumption is going to data centers. That actually is going to increase, but there is a limit to which content is best in those locations. The second tier in that distribution are these cached or distributed caches of data and computing power around the world. And we're seeing those deployed much more extensively in the Pacific Rim over the past decade than we have in the past. And we're starting to see that same model now be pushed into Latin America, Africa, some Central Asia, some less developed markets where teledensities are much lower. But the real revolution comes in that end user device, the phone, and all of that computing power that is now in the hands of those individuals. Remember, nearly 90% of the individuals that access the internet regularly do so only through a mobile device. Wireline is far superior. Wireline can lower that cost of connectivity and increase the bit intensity of those models. So we are in a discovery process where the market and pricing models are helping us figure out which applications and which content is best delivered wirelessly and which are best delivered over a wireline network. That transformation is still ongoing. You know, video, which today dominates the internet, is best delivered over a wireline network. Wireless networks, even with 5G, do not have the cost efficiency to deliver streaming video to every end user cost effectively. Remember, video used to always be delivered via a wireless model, but it was a broadcast model. We were multicasting to many users. But one of the advantages of the internet has been the evolution of unicasting. Basically, the ability for people to time shift and the ability of people to pick content that is particularly interesting to them and relevant. That unicasting model uses orders of magnitude, multiple orders of magnitude, more bandwidth than you did in a broadcast network. It fragments society. It turns every individual into a publisher, whether on the Meta platform or the Twitter platform. They are able to publish to end users in a way that was never possible before. So what we have seen is true societal transformation. Many countries struggle with this. I would say today the majority of companies and countries in the world are still struggling with what an open internet means. What does empowering your citizenship to be able to speak? And then when is that speech inappropriate? These are things that are far beyond the network layer. They reside at the application layer. We as service providers should not be involved in those decisions. Our job is really one-dimensional. That is to get more people connected at lower cost relentlessly. If we do that, then the market will figure out the application layer. And if you think about the way the internet works, those legacy access networks have all been under significant pressures financially, and that's going to continue. The capital is flowing into the next generation networks. This is natural. This is a good evolution. You know, people will say, well, you're just a fiber bigot and you don't look at any other technology other than fiber. And to me, it's basic arithmetic. I am sure at some point in time there will be a new technology that replaces the internet, and there'll be a technology that replaces fiber as an end distribution media. But that's not here and now. For the next 20 or 30 years, and that's about as far into the future as we can see, the internet is going to be what dominates. And the real challenge in deploying this incremental capital profitably is to get enough market share quickly enough. Because if you are a fiber overbuilder in the access market, you have 3 embedded competitors for what should be a natural monopoly. You are competing with people delivering over vector DSL. You're competing with service providers using 5G. And you're competing with service providers with coax, if it's available. Coax is not as ubiquitous as the other 2 technologies, but it is a higher throughput. Fiber is the best end user solution. And one of the challenges that the Pacific Rim is going to struggle with, just as the rest of the world is struggling, is how to profitably incent investors to put capital in to build those next generation networks, and yet at the same time ensure that pricing is affordable and access is unregulated. And that access control can occur 2 different ways. One, it can occur through government fiat. The government comes in and says, we don't want to let X go across the network, whatever X is. You know, for those of you that have worked outside of China and have tried to serve inside of China, the Golden Wall, the national firewall, makes certain applications very difficult to deliver inside of China. And there are national champions that the Chinese state government promotes, and competitors are disincented from those markets. But the second level of censorship, and I'll use the word censorship, comes about from access providers trying to charge tolls to get to end users. We at Cogent have been at the center of many peering fights. Many people kind of associate Cogent with those fights. First of all, we are the most interconnected network in the world. 7,800 ASs directly connected to us, over 26,000 simultaneous BGP sessions, literally hundreds, thousands of terabits of connectivity, BGP sessions operating in over 1,500 endpoints around the world. So we can speak about connectivity, but we have seen certain local network operators unwilling either to buy transit or provide peering to connect to their end users in an attempt to monetize those applications. Rather than embrace the new, they have looked to block it, to put a toll road in place. We have not seen at Cogent as much of this in the past 5 years as we have seen previously, but it is still a significant problem. And service providers need to get away from that monopolist tendency of thinking they own their customers' eyeballs and they can in turn charge for access to them. The innovation on the internet comes from its ubiquity and its openness. You know, Bob Metcalfe, when he invented Ethernet, coined the term, the value of the network is equal to the square of the number of users. I actually think that dramatically understates the value of the network. It's really the square of the number of users times the percentage of their day they spend on the internet, and then most importantly, the value of the application that they're spending their time on. And again, because this is a decentralized model with millions of applications, every consumer gets to make those choices. That is why the internet has succeeded. That is why we had the infrastructure in place when the world locked down to continue to support all of our businesses, support remote work, and allow societies to continue to function. The chaos that would have been had through the pandemic 20 years ago would have been far worse. Yes, there are millions of people that have died from COVID. That is very bad. I'm not trivializing that at all. But what is critical, as professionals, we should feel very proud of the fact that we help the world continue to function and operate, people to communicate, businesses to innovate. But the innovation has just begun. If you think about the way business models have developed on the internet, for the most part, they've all been ad-based models, free. And that's an important part of our society, but less than 1% of global GDP gets spent on advertising. So there's a huge number of other business models that will be subscription-based, will be fee-based, but will empower supply chain innovation, globalization, remote distribution, remote manufacturing in ways that we have not yet begun to conceive of. And again, it is this decentralization of innovation that is really at the heart of what the internet is about. You know, the original engineers that were at the first analog and sat down and said, well, we want this network where people just peered with one another and interconnected, really had no idea how transformational that would be. They were focused on the simple bit economics of moving from a circuit switch world to a packet switch world. And those are fundamental, but they are not nearly as important as decoupling the application from the network. Voice networks were built to carry voice. Cable networks were built to distribute one-way video. Private data networks were built to connect locations together. But the internet is a network that fosters all of these different business models. Everything's porting to the internet, but more importantly, all of these new models are being developed. And we as service providers need to make sure that the decisions we make are twofold. One, they're providing adequate return to our investors, because investors are smart. If you don't generate returns for them, the money will go somewhere else. It'll go into a different industry. And we need capital. There's a huge amount of innovation that still needs to occur at the network level. But the second thing we need to do is we need to make sure that we remain transparent to the application. We become an enabler, not a censor. We don't become a gatekeeper, we become an enabler. That is our model. That is what we need to do. And that's a difficult ask, particularly for some of you that have an internet part of your business, but there's still a significant legacy telco business, whether it be voice or private data, and you're struggling with those declining revenues. The internet is deflationary. In the developed world, telecommunications services peaked in 2000 at about 4.5% of GDP. Today, it's 1.2% of GDP. And probably over the next decade, if we do our job, it'll be 0.5% of GDP. I remember sitting down with the CEO of a large incumbent telco one day, and he came to my office and we were chatting, and I was kind of wondering why this guy from this company, literally 1,000 times bigger than Cogent, was coming to talk to me. And he came in and he said, we have to stop Facebook. This was a decade ago. And I said, why? Well, why do we have to stop Facebook? And he says, well, they're getting a free ride on our network. And they're making all the money and sucking all the profit out of the ecosystem. They're our enemy. And what I said is, you're thinking about this exactly the wrong way. If you want to be in Facebook's business, go out and create your own social network. Or better yet, come up with some new application that consumers are going to want to use. But we as service providers should welcome those applications. And it is that openness on the internet that has allowed it to flourish and to grow. So when I think about the internet and its future, I think about a network that is just beginning. There are many new applications, many new innovations, and much lower costs in our future. So we, as service providers, need to commit to that. The internet will be more important in the Pacific region. It'll be more important in the rest of the world. You know, what I'd like to do, and hopefully this won't offend my PTC hosts, is I've got about 5 minutes left. I'm happy to keep talking, but maybe there's a couple of questions from the audience that I could try to answer. Yes, ma'am.
What makes your company different than other providers that are doing the same thing?
Okay, so I'm going to repeat that for the people in the back. What makes us different than other service providers? So we built the company with 6 basic pillars. And those pillars are still true today. 1, the internet would be the only network that mattered. 2, local access is a monopoly. So as an overbuilder, we needed to be thoughtful about where we build. 3, scale matters. Telecom is an industry where marginal costs are always below average costs. So that meant you had to get big quickly. 4th, your largest single cost is sales and marketing. Well, it's impossible to outbrand an incumbent. So the way you do that is by delivering more value to your customers. Value lowers your cost of subscriber acquisition. 5th, you needed to have a network that would be able to monetize those advances in technology more effectively than others. Legacy networks have heterogeneous products. They were built on a TDM platform, and they were not able to capture the advances in wave division multiplexing and optically interfaced routing near as effectively as an all IP over DWDM network built on a land architecture. And the last thing we did, which was controversial, is we didn't build fiber. We bought fiber from 306 different providers around the world. So we thought it was more cost effective, it was a quicker entry to the market for us to go out and buy dark fiber. We don't buy lit services, we buy dark fiber. We then light that and effectively run a local area network on a global scale dedicated to selling internet connectivity. So those were the basic pillars, but there's another key difference. We had the discipline to say no to lots of different temptations, whether it be customers, whether it be investors, whether it be competitors, all trying to pull us into moving up the value stack, selling a wider number of services. We stuck to our knitting. Cogent's motto, which some may find offensive, I think is something we should be proud of, and that is smart people buy dumb pipes. We, again, as service providers, need to get comfortable. That's our role in this ecosystem. We are not good at selling applications. Let others do that. We are not trying to vertically integrate. We are not trying to sell value add. Our strength is at the network layer, and that's where we need to focus. Yes, sir.
What are your thoughts on wholesale fiber for access? Do you think that telcos and ISPs should be doing vertically integrated FTTX, or should they have wholesale plays?
So the question is, on local access, should dark fiber be available for purchase versus a service provider retaining that fiber to sell its service to end users? I am a big proponent of structural separation as the only model that will eventually generate adequate returns and promote ubiquity of fiber. There is a need to separate the service part of a provider from the network part of the provider. That's controversial, and many of the current deployments, whether it be BT Openreach or Telstra in Australia, some of the Swedish applications, none of them have been implemented effectively, and people point to those and say, that model failed. The reality is local access is a monopoly. We should not have two fiber builders over the same footprint. Your cost of deployment is proportional to homes or businesses passed. Your revenue is proportional to homes or businesses served. That means you need to pass as many homes, but you need to get them as customers as quickly as possible. The best way to do that is by selling your open access network to dozens of different business models. You may get content guys who want to give it away for free. You may get customers who want to pay a premium for an application or a service. Open architectures are best, and that will promote ubiquitous internet deployment. I see I'm wrapping up. Thank you all very much, and hopefully I didn't bore you. Take care.